Hello, my name is Alex May, and I am a UC Santa Barbara's master's graduate, and today I will be presenting our paper on covertly unsafe text. This cross-institutional project has previously appeared at EMLP 2022. This presentation contains examples of harmful text, so if you're uncomfortable, please feel free to look away or skip that part of the video. The current age of digital media has raised concerns about people's physical safety. To address the concerns of physical harm, our paper concretely defines the term using degrees of separation away from the physical harm. 0 degrees of separation indicates overtly unsafe text, which can be characterized by explicitly violent keywords such as shoot or kill. 1 degree of separation represents covertly unsafe text, which has an additional element of reasoning needed to realize the physical harm. 2 or more degrees of separation denotes indirectly unsafe text, which is not actionably unsafe but may encourage future physically harmful behavior toward others as well as physical harm. We focus on covertly unsafe text as it is more subtle than the overt counterpart yet equally dangerous. To break down covertly unsafe text further, we denote 3 types. First, there is limited information, where additional context is needed to comprehend how the physical harm could be caused. For example, suggesting someone to try the cinnamon challenge would be covertly unsafe because the action is dangerous, but you would need the additional context that cinnamon can clog airways. Next, there is conflicting information where multiple recommendations may be safe individually, but the combination raises an unsafe situation. Finally, there is incorrect information characterized by language that contains non-factual information. Covertly unsafe language may also span many domains. In this slide, we break it down into 4 primary categories. First, there's the outdoors, which describes scenarios typically occurring while in nature or traveling, such as dealing with quicksand. We also identified the medical and household as primary domains, as well as the catch-all category. To address these issues, we propose 5 primary technical directions. First, we must acquire the data needed to train and evaluate our models. Next, safety-specific metrics would be beneficial to measure progress in improving safety. On the model side, controlled text generation could be a fruitful strategy to mitigate unsafe generations. Integrating knowledge through external sources or information retrieval could aid the reasoning process. And finally, improving explainability of black box models can provide safety-specific insights. It's also important to consider an interdisciplinary approach to improving AI safety. On the policy end, while legislation is still in early development, concrete developments need to be made to protect consumers. We should also further emphasize a human-in-the-loop approach to integrate diverse perspectives and stakeholder discussions to mitigate potential biases that may span from different perceptions of safety. Finally, social workers can help bridge the gap between impacted communities, regulators, and computer scientists. Particularly, as models are prone to hallucinations, it is important to emphasize the need to exercise caution instead of blindly trusting AI systems that may be subject to misinformation. Since the release of our paper, there have been some follow-up research. SafeText is a dataset that contains examples of covertly unsafe scenarios. When evaluating language models out of the box, the authors observe high misclassification rates on these examples. To address these issues, my ACL 2023 paper proposes FARM, a pipeline problem-solving technique that foveates on missing information, attributes credible knowledge from trustworthy sources, and then rationalizes with in-context inference to generate human interpretable rationales. Finally, the position paper, Users Are the North Star for AI Transparency, argues for a user-centered evaluation criteria for research to better align the desired ends of researchers, such as safety, with their employed needs. To conclude the presentation, we define the problem of covertly unsafe language by framing it as degrees of separation with respect to physical harm and discuss concrete mitigation strategies. We emphasize taking an interdisciplinary approach toward tackling the issues of physical harm in AI. Finally, we introduce follow-up work that builds on this idea of covertly unsafe language. If you're interested in learning more, please scan the QR code. Otherwise, thank you for watching and listening.